All right, we want to look now at section 7.3. Probably only one video here. There's not very much in 7.3. If you've noticed in your homework, there's not but 4 problems in section 7.3 on this particular topic. So what I'm going to do is move out of the way. I want you to pause the video and just copy everything that's behind me. Once you copy it, then you can unpause the video and I'll talk a few minutes about where we're going. So let me move out of the way. Pause the video now and copy this down. Okay, you should have this down. Now let me explain to you, before I get to this, let me explain to you what we're going to be looking at. What we're going to be looking at, if you remember on your test 1, we talked about graphing lines. We talked about how to plot points and how to graph a linear equation. We talked about how if you had 2 points, how you can find the slope of the line that goes through those 2 points. Remember what we did, if I give you 2 ordered pairs and you plot them, there's a line that goes through those 2 ordered pairs. How do you find the slope of it? One way was by using the slope formula. So what we did, I gave you 2 ordered pairs and we went to the first ordered pair and we called that first ordered pair x1, y1. We moved to the other ordered pair and called it x2, y2. And then we took those 4 numbers and we used the slope formula. It was little m equal y2 minus y1 over x2 minus x1. And you use the slope formula to find the slope of the line that goes through those 2 points. Now what I want to do is, I want to show you, if I give you 2 points on a graph, how to find out how far apart they are. We call it the distance between the 2 points. Not only that, I want to show you how to find the point that is exactly halfway in between the 2. So, you don't have to draw this, I just want to show you. So, if I have a point here and a point right here, how to find out how far apart that is. Now, I'm just going to call this point P and this point Q. So when I say find D of P comma Q, that just simply means find out how far apart they are. So in other words, if you was to walk this, how far apart are they actually? Now, here's the reason you have to have this formula. If the 2 points are straight across from each other, because see, we can count left and right, and we can count up and down. So if the 2 points are straight across from each other, all you have to do is count the spaces. The problem is, in the XY plane, we can move left and right, we can count left and right, and we can count up and down, but we can't count diagonally. So in other words, I can't count this way, like I can left and right. Now, I can give it a guess, but I can't give you, exactly how far apart those are. So what this distance formula does, it gives you the exact distance on how far apart those 2 points are. Now the midpoint, so the distance, your answer is going to be some number. Now the midpoint is the point that is halfway in between this one and this one. So we call that capital M, not little m. Remember, little m stood for slope. M of P comma Q is the point that is halfway in between these 2. So the midpoint will be an ordered pair. The distance will just be a single number. Now, you copied down a while ago the distance formula and the midpoint formula. So here's what we're going to do. And we're only going to do one of each of these because they all work the same after this. So I'm going to give you 2 ordered pairs. And I'm going to ask you to find D of P comma Q. That means to find the distance between P and Q. Now, it doesn't have to be called P and Q. It could be called D of A comma B. So I could call this A and B if I wanted to. But to stay consistent with your homework, I'll call it P and Q. So we're going to find out how far apart these 2 ordered pairs are. And then we're going to find the point that's halfway in between these 2 ordered pairs as well. So let's look at this one example that you just wrote down. So I want to find out the distance between these 2 points, and I want to find the midpoint between these 2 points. I want to do one other thing. Don't copy this, because this is going to be off some because I'm freehanding it. But I still want to just show you. So don't write this down. If I plot 5, -6, -6 is roughly here. That's where 5, -6 is. To the right 5 and down 6. Now -1, 4 is to the left 1 and up 4. So -1, 4 is about right there. Now what I want to do is, I want to do 2 things. I want to find out how far apart this point, and by the way, this was Q, and this was P right here, and P was -1, 4. So I want to find out how far it is from here to right there. I want to know how long that is. Not only that, I want to know the point that is halfway in between, P and Q as well. Now, before I use the actual formula, what I want to do is I want to just give this a guess about how far it is from here to here. Now, let me show you how I can give it a guess. 1 unit is from here to here. So 1 unit is that distance right there. So what I'm going to do is I'm going to use this distance, and I'm going to follow this path. So let's see, that'd be about 1 right there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if I had to guess about how far it was between P and Q, I would say somewhere between 12 and 13 units. Now, what's a unit? A unit is how far I made my 1 be. So if you draw your graph a little differently than me, it'll be further apart. Now, the distance won't be, your answer should still be somewhere between 12 and 13. So if I had to just guess how far apart these 2 points are, I'd say somewhere around 12 or 13. Now, you're not having to do this graphically, so I just want to show you that the formula will give us an answer that's actually going to be about 12 or 13, somewhere in that ballpark. All right, so here's what I want to do. I'm about to put up the first part of this problem is the distance part. I want you to copy it, and then after you copy it, I will go over it with you. So let me put it up. And I'll refer back to this in just a minute. So what I want you to do is pause the video now and copy this problem. Pause the video now. Okay, I'm assuming that you copied this, so let me go over it with you. All right, so just watch me now. You're given the ordered pair. Now, it will not be labeled for you. Now, remember, the instruction said find the distance, and if you want to put, let's see, this was P, and this was Q. So, if you call this D, P, comma, Q, that's the same thing as capital D. So, I'm showing you this because this is the way it asks it does it in the homework. All right, so what you do first is you label X1, Y1, X2, Y2. Now, that labeling will never change. So this is a XY, first point, XY, second point. Now, take these 4 numbers and plug straight into your distance formula. Now, in order to use your distance formula, you have to memorize it. So I've got to memorize the distance and the midpoint formula for the final exam. All right, here's the distance formula. Now, X2 is 5 minus X1 is -1. Yes, you have to put another negative, but make sure you get the right number. Square plus y2 is over here, that's negative 6, minus y1 is over here, that's 4. Close the parentheses and square it. Orders of operations, do what's in parentheses first. Double negatives gives you a positive. So this is 5 plus 1, which is 6 squared. And then negative 6 minus 4 is negative 10 squared. So do what's in the parentheses first. Now square the two numbers. 6 squared is 36. Negative 10 squared is negative 10 times negative 10, which is 100. Now remember, when you're adding under a square root, you can't do them separately. You can if you're multiplying. You can if you're dividing. But you can't if you're adding and subtracting. So you have to add the two numbers together first. All right, square root of 136. Now, the computer does not want a decimal answer, nor will I. It will say, give your answer in reduced radical form. Well, square root of 136 is not a perfect square root. You don't believe that? Take your calculator. It's not a whole number. So what you have to do is reduce this. We talked about reducing back in the previous section. How do you reduce a radical? If it's divisible by a perfect square. Well, 4 goes into 136, and it's the only perfect square that goes into 136. Also, remember I told you that your calculator will do this for you. Most calculators, if you are in the right mode. So, right here, take square root of 136. Break it up as 4 times 34. Then break this into two radicals to get a final answer of 2 square root of 34. Now, what I want to do for you is just show you right quick. If you've got your calculator with you, take your calculator and punch in the square root of 136. If you do, square root of 136 is right at 12, 11 point something. Well, what was our guess? Our guess was between 12 and 13. So I'm off just a little bit because I freehanded this. But the exact answer is somewhere between 11 and 12. The reason is square root of 144 is 12. So this is a little bit under 12. So I wasn't very far off even though I was freehanding it. So right at 12 units apart. But this is the answer you will need to enter on the homework. Okay, copy this part right here now. Freeze the video now and copy this. Okay, I'm assuming that you copied this. Now let me go over this. Unlike the distance formula, the distance between 2 points is a single number. It's a decimal most of the time, though we don't write it as a decimal. What was the distance between these 2 points? 2 square root of 34. What was that? About 11 point something. I don't know. I don't have my calculator, but it's like 11.8, something like that. So the distance between 2 points is a single number. The midpoint is an ordered pair. It's a point. That's why there's a comma in this formula. So you need to memorize this formula. It's capital M because of the midpoint. Now plug in your numbers. x1, if you'll look back up the way we labeled it, is negative 1. Plus x2 is 5. Make sure you get the right numbers. Divided by 2. Comma. y1 is 4. Plus y2 was negative 6, if you'll look back up, over 2. Now, negative 1 plus 5 is 4 over 2, comma. 4 plus negative 6 is negative 2 over 2. And 4 over 2, in this case, reduces to 2. Negative 2 over 2 reduces to negative 1. No, your midpoint doesn't have to be a whole number. If this had been 5 over 2, I would have just left it 5 over 2. So anyway, do reduce your fractions. All right, so 2 comma negative 1 is the point directly in between those 2 points that I plotted a while ago. Well, let's look at that. Let me go back to the graph. Remember, 2 comma negative 1. Here was the graph. Now, and again, remember, I may be off a little bit because I'm freehanding this. So 2 comma negative 1 is to the right 2 and down 1. And you can see, if I was just guessing, does this point look halfway between here and here? Yes, because that distance looks the same as that distance right there. So that midpoint formula, that's your midpoint. We called it M, P, comma, Q, was 2 comma negative 1. So this section shows you how to get the distance and the midpoint between any 2 given points. So the problems you've got for homework, you will be given 2 ordered pairs, and you will be asked to find either the distance or the midpoint, or maybe even both. So make sure you pay attention to the instructions when you're reading those. So this concludes section 7.3, distance and midpoint. Now we will move in the next video to section 7.4.